Okay, so today we're going to talk about 1.5, solving inequalities in one variable. So remember, whenever we're solving an inequality, this is going to be the same method as solving an equation, unless we multiply or divide by a negative. Then we must flip the inequality sign. Okay, so if we look at this first one, we have 7x minus 3 divided by negative 4 is less than 6. So to get rid of our fraction, we're going to multiply both sides by our negative 4. When we multiply on the left, they cancel. So we're left with 7x minus 3. Then since we multiplied by a negative, we want to be careful that we flip our inequality sign. So instead of less than, this becomes greater than. And 6 times negative 4 is negative 24. We're going to add 3 to both sides so we can get our 7x by itself. So 7x is greater than negative 21. Divide both sides by 7. So x is greater than negative 3. Okay, so now we're going to graph. So in previous classes, we've talked about graphing inequalities with open and closed circles. We're going to change that up a little bit. Okay, so remember when we have less than or greater than, we would normally do an open circle. Less than or equal to or greater than or equal to, we would normally do a closed circle. Okay. Instead of that, now we're going to use a parenthesis, depending on which direction we're going, or a bracket. Okay. So I'm going to make my number line. And since we are greater than, we're going to have a parenthesis. And since it's greater than, we're always going to go the direction in which our inequality is facing. So at negative 3, I'm going to put a parenthesis facing the right. And then we're going to shade everything to the right. And then darken your arrow. Okay. And then another new concept is interval notation. Okay. With interval notation, we're going to match our graph. So we have a parenthesis at negative 3. And we're going to keep going. This arrow is going to keep going on our number line to our positive numbers, and they keep going all the way until positive infinity. So I'm going to bring that down, and infinity always has a parenthesis. Okay, always uses a parenthesis. And that would be your solution. So that's our interval notation. This is our inequality. And then here we have our graph. All right, so now let's look at B. We have 2x minus 5 is greater than or equal to 5x minus 22. So I always like to move my x's to the left with inequalities. So I'm going to start off by subtracting our 5x. And 2x minus 5x is negative 3x minus 5 is greater than or equal to negative 22. Then to get our negative 3x by itself, we want to add 5 to both sides. So we have negative 3x is greater than or equal to negative 22 plus 5. It gives us negative 17. Then to get x by itself, we're going to divide by negative 3. So x, we divided by a negative. So remember, we need to flip our inequality sign. So it becomes less than or equal to. And a negative divided by a negative is a positive. We don't know 17 divided by 3, so we're just going to leave it as an improper fraction. Okay, for our graphing though, it's better if we go ahead and write this as a mixed number. So let's go ahead and figure out what that would be. So we have x is less than or equal to. So 3 goes into 17 5 times. 5 times 3 is 15. So we have a remainder of 2. So we're going to have 5 2/3. So to graph this, we have our number line. So 5 2/3 is going to be in between 5 and 6, but closer to 6. I'm going to put a line there. And since it's less than or equal to, we're going to have a bracket. And then it's less than, so we're facing to the left. And then I'm going to darken this all in. Okay. So then on our number line, we have negative infinity as we go to the left, positive infinity as we go to the right. I'm going to write that in. So we can write our interval notation. I'm just going to abbreviate that, IN. So again, we're going to match our graph. So we're starting from left to right. So we have negative infinity, which always uses a parenthesis, going to our 5 2/3, but I'm going to take that back to the answer we originally found, 17/3. And there's our interval notation. Okay, looking at C, we have negative 2 times the quantity 4x minus 2 is less than negative 8x plus 4. So we're going to start off with distributing. Negative 2 times 4x is negative 8x. And negative 2 times negative 2 is a positive 4, which is less than negative 8x plus 4. Notice we have the same thing on both sides of our inequality, but that doesn't mean it's an identity. Identity only works when we're looking at an equation. So let's go ahead and keep solving. So if we add 8x to both sides, this cancels. So 4 is less than 4. Is that true? No, it's false, which means we have no solution. Which a lot of times we also write 0 with a line through it. And then your number line for your graph is just going to be a blank line. Okay. And that's C. All right. Looking at D, we have negative 6x minus 5 is less than negative 3 times the quantity 2x plus 1. So again, let's start by distributing. Our left-hand side stays the same. Negative 3 times 2x is negative 6x, and negative 3 times 1 is negative 3. We're going to add 6x to both sides, and these are going to cancel. So -5 is less than -3. That's a true statement. Because remember, with our negatives, we always think backwards. So since it's true, if we wanted to graph this, it's true for all values from -infinity to +infinity. So for your graph, we're going to darken the whole line. For just our general statement, we can say all real numbers. Similar to what we did with an identity. And then for our interval notation, we graphed the whole line. We went from -infinity to +infinity with parentheses around both. Okay.